Imagine a contest where participants have to move the weights from one place to another. Whoever moves the maximum number of weights in 10 minutes wins. Before the contest starts, the contestants are given the energy drinks. Suppose a contestant moves 5 number of weights 10 kilograms each in 10 minutes from A to B. Now here comes the concept of work, power and energy. Energy is nothing but the capacity to do the work. Before the contest, the energy drinks which was given gave the contestant the capacity to lift and move the weights. More the energy drinks given, more is the capacity to do the lifting. Similarly, greater the energy of the system, greater is the capacity to do the work. The unit of energy is joule. The contestant has to move the weight and move from one place to another. In other words, weights were displaced by applying the force on them. This is the work done on the weights by the contestant. In physics, the work done is defined as the product of force and the displacement produced by the force. W equals to F multiplied by S. The unit of work done is equals to joule. Of course, this is the simplest equation of work done, and the equation changes as the situation changes, which we are going to discuss later on. After the contest, the result for the contestant was that in 10 minutes he moved 5 number of weights. This is the power, which means how much work was done in a unit time. Power equals to work done divided by time taken to do the work. The unit of power is watt. Now we know the relationship between energy, work and power. There are varieties of situations where the equation for the work done changes. If a force is applied on a body and the displacement is in the same direction as the force, then the work done is equals to product of force and the displacement. But if the force and the displacements are in two opposite directions, making an angle of x between them, then the equation for the work done changes. Then the work done is equals to component of displacement in the direction of force multiplied by force, or component of force in the direction of displacement multiplied by displacement. Through either of the equations, we get the work done is equals to force multiplied by displacement multiplied by cos x, where x is the angle between the force and the displacement. Here, the value of x can be anything. If the value of x is 0, which means force and displacement are in same direction. If the value of x is equals to 90 degrees, it means that the force is perpendicular to the displacement. In this case, the work done is equals to force multiplied by displacement multiplied by cos 90, and the value of cos 90 is 0. So therefore, the work done by this force will be equal to 0. If the value of x is equals to 180 degree, it means that the force and the displacement are in opposite direction. So therefore, the work done will be equal to force multiplied by displacement multiplied by cos 180 degrees. But the value of cos 180 is -1. So therefore, the work done will be equal to minus Fs. Let's take another example. Suppose a block of mass m is lying on the top of the slope. After few minutes, the block slides down to the bottom of the slope, covering a distance of L. The angle of the slope is x degrees. The question is to find out the work done by the normal force and the work done by the gravitational force. Here, the normal force is acting perpendicular to the slope and the displacement is along the slope, making an angle of 90 degrees between them. So therefore, the work done will be equal to 0. The gravitational force is acting downwards with a magnitude of mg. This angle is x degrees, this angle is 90 degrees. So therefore, this angle between the force and the displacement is 90 minus x. So therefore, as per the previous discussion, the work done is equals to component of force in the direction of displacement multiplied by displacement. The component of force in direction of displacement is equals to mg cos 90 minus x, and the displacement is L. So therefore, the work done will be equal to mgl cos 90 minus theta, which is equals to mgl sin theta. Now there are varieties of questions for which the work done can be found out, but the basic principle remains the same. If this video was helpful to you in understanding the concept of energy, work and power, comment down below to us. If this video helped you, please share the video to help others. Thank you.